So welcome, myself Dr. P.D. Kumar, Professor Head, Department of Automobile Engineering, Hindustan's Institute of Technology, Coimbatore. So today we are going to see about CFD, that is computational fluid dynamics. So before getting to the subject, so what are the opportunities if you learn CFD? So it is unlimited. If you take our central organization like ADA, HAL, DRDO, NIL, ISRO, GTLE, DRO, DIL, BAR, PSSC, ARI. So you can tell many research centers as well as GE, General Motors, Honeywell, Airbus, Bose, Delphi, Rolls-Royce. So there are a lot of MNCs and companies they are using computation. Whether they can use commercial package like Pliant or Star CD or CFD SE Plus or something Phoenix. Somebody they will use OpenFOAM, then otherwise somebody will use their own code. So if we take our descents, DRDO, they have own codes. So and also many companies. There are different companies that are offering CFD codes, that is CDR.co, Cosmo, Comson, CSM, that is Star Series or CC Plus, ESC Groups, and Pliant, and ANSYS India and all that. So there are different consulting companies, Cost, Satyam, Tata Technology, TCS, Infosys, Infotech, HCL, CC Tech. These are the companies that can get the opportunities. So then coming to the subject, what is computational fluid? It's the analysis of system involving fluid flow, heat transfer, and associated phenomena such as chemical reaction by means of computer-based simulation. Simply saying, it is a numerical techniques to solve the mathematical problem or any physical definitions or physical structures or any fluids. So normally there are triangular way you can tell us theoretical fluid dynamics, experimental fluid dynamics, and computational fluid dynamics. Computational fluid dynamics means virtual fluid dynamics. It's called mobile technology, mobile tunnel method. Okay, mobile wind tunnel. Okay. So analytical comes near to theory and as well as computation. So theory, it should be a social oriented or society oriented. It convert into experimental. Experimental having lot of feedbacks. Based on the customer feedback, it has to again we have to change the model or optimize the model or redesign the model. So if you do every time, the cost will be higher, the time consumed will be higher. Instead of that, you can use computational fluid dynamics, that is a virtual simulation. You can find out. So what will happen if the design is changed, if dimension is changed, or the environment is changed, or otherwise fluid properties, any flow is changed. What will happen? You can simulate many times, you can orientate many times, you can scale up, scale down. That is computational. That is capable of computational fluid. So can you remember these space? That is Newton, Euler, Bernoulli, Stokes, Navier-Stokes, Reynolds, Randalls. These are how they are beautiful. So this was very important process of fluid mechanics as well as computational fluid. So without Navier-Stokes, without Bernoulli, without Newton, without Euler, without Brandon, we cannot able to define computational fluid. These all members mathematical and coding for that. So if you want to study CFD, your entry behaviors will be a knowledge in fluid mechanics, heat and mass transfer, numerical methods, and defense elevation, both ODR and PD. So normally fluid mechanics is a branch of science which deals about the study and behavior of fluid when in rest or motion. If in rest it is called statics, if it is motion it is called fluid dynamics. So this again is converted into laminar and turbulent. So based on the Reynolds number, the laminar flow also defined and also further is defined. Again, the fluid will be Newtonian and not fluids. If the real fluid which obeys the Newton law of viscosity is called Newtonian fluid, if it doesn't obey the Newton law of viscosity, it's called non-Newtonian fluid. Again, ideal flow of viscosity. If you have possessed viscosity, it is called viscous fluid. If it doesn't possess, it is called ideal fluid. It is again compressed flow and compressed. Based on the density variation, this compressed flow. The density doesn't rate is called uncompressed. It is lost is the best example in this case. So CFD, it is started in 1946, something like this. It is 1990. This came only for aerospace and defense. Then it is CFDs everywhere. Wherever the heat transfer, wherever the fluid flow, you can use computational fluids. So history started from 1960. Now it is moving to everywhere. Aerospace, automotive industries, any kind of industries you can use. So it is a predictions. Already told you, analytical, theoretical, and experimental. So this is the path of coding computational fluid dynamics. Now the physical problem is converted to first differential equations using this discretization techniques like finite element, finite difference, finite volume method. These positive differential equations convert to a system of algebraic equations. So this algebraic equation you can here apply the boundary conditions. So then you can use the values you can apply is this is again converted to numerical by using matrix solver, either that method or indirect method. This complete part will be coded in any C++ language. So you can write your own code, you can write your own software. That is your one of the software. If you want to write your code, you can write it. If you want to interact, you can make some GUI graph user interface. You can put Visual Basics. If you want the database, you can use Microsoft like this. So this complete software package is called CFD software. You can write your own source code also. So this is overview of CFD. Okay. The CFD process start with, if you go to any commercial package, start with geometry. Based on the physics, geometry will vary. The physics, the heat transfer, compressible, flow properties, you have to include 9 properties: viscosity, density, weight density, then bulk mass, compressibility, vapor pressure. So many properties are there. Viscosity is very important properties you can mention. Based on that, you can define the laminar turbulent flows. So boundary conditions you have to mention it. So mesh you have to create that the continuum, that is complete structure you have to create to small pieces or small elements, small volumes. So either structure and structure. There are 2D, in case of 2D is triangle and quadrilateral, in case of 3D is tetrahedral, quadrilateral, something like etc. So can use solver, steady or unsteady, iteration or steps methods, or conventional limits. The steady and steady means based on the time it will vary, it's called unsteady, it is based on time response in constant is called unsteady. So you can write the report, you can plot the X-ray plot, you can get the standard plot, you can get the animations, you can get the vector plots. This is called the post-processing. So this primary phase is called pre-processing, this is solving, this is post-processing. This is complete CFD process, which is all it is common to all CFD software. So the same thing as what I told you, the pre-processing, this is solver, this is post-processing. This is complete structure is encoded in the CFD package like client or CFD or C++ or star CFD, something like this. So geometry may be very simple or something like more complex like diagnosis, mathematical elements of volumes. This is geometry equations. As already told you, you can use CAD model. In a CAD package, you can define the geometry. From the geometry, you can discrete the geometry into small pieces or small units. It's called grid or mesh. So you have to enable the positive equation for this. So based on this equation, either conservation of mass or conservation of momentum or energy. So whatever applicable, you can use this used equations. You can simplify them. These are the 2D elements. These two are 2D elements. These are the 3D elements. This is triangle and quadrilateral. These are 3D elements. So for 2D phases, so elements are like this. For 3D phases, elements are like this. So normally I told you the governing equations consist of conservation of mass, momentum, and energy. These three is for the initial equations. Why CFD? Why we have to go CFD? If you do any experimental, it is more costly, expensive. If you do simulation, it is cheaper. It is very slow in case of experimental work. It is so fast in simulations. Sequential, it is fast. It is simple purpose, it is not. So you can save the time, and also you can do many orientation information. So simulation is better and reduce experimental. So advantages already told you the low cost advantages. If you simulate in the way, it is also. The limitation is some errors are there, round of error, translation error, inversion errors. It is from at least 3 to 4% will be there. So all the software will be approximately from so applications are plenty. If you take aerospace companies, there are plenty of applications. If you can define the nose body, how the nose body, what will be the track coefficient, what will be the net coefficient, what will be the pressure, how to model the nose, how to define the nose. Even you can use automotive, you can define the aerospace model. This is biomedical application you can use. Is even hot pumping you can use computation. In chemical mixing of two fluids, heating and ventilation air conditioning systems, you can define the heat load calculation and refrigeration load calculation. You can use CFD. So you can, in case of marine, in case of any civil structures, you can use computation programs. In case of vehicle speed, find land speed, and also it is aerodynamic studies, and also in case of mines, you can use CFD. Sports and regulations, you can use computation programs. Because of platforms, internet from inside the engine, how the combustion is taking place, and how the lubrication is taking place, how the cooling is taking place. So that you can study the weather and climate trends and other industry everything with this combustion. So all industries are this. So even you can define, you can use for all turbo machine like pump, compressor, fan. Even in the case of blower, and also some valves. It is a globe valve with a computation programs. In kind of fans. In case of computer CPU, you can above the CPU there is a fan. That to cool the CPU there is a fan available. You can define how the force conductor is taking place. Once it transfer in this particular electronic component, you can see this. So this is a typical of globe valve. It is modern Pro E application help mesh. You can do simulation plant. This is also some one of the fan models. This is some just manifold. This is brake drum. This is some blowers. You can use safety. So we don't this is some flow to the injector. How the injecting is still plus all the nozzle operation of nozzle, how the velocity, how the mixing professional to check it out. Even flushing rate of the barrel tire you can use CFD. You can use CFD wherever the flow, wherever the heat change, you can use computational programs. Mixing of this is a washing machine, typical washing machine. You can find out the complete washing capability of the color. This is actually 150, it is 150 RPM. How the flushing is taking place as well. In case of furnace also, you can use CFD to find out the combustion, the complete combustion and complete combustion you can study based on the time. So complete combustion you can use CFD. So you can use lot of, if you have the time, if you have an idea, you have the knowledge, you can do the magic in CFD. Okay. So these are the applications. Here the heat is also used to find out the heat transfer rate, different of heat transfer, different of pitch and of tubes, even silent tube heat exchanger, how the pass will be, whether the pass is effective and ineffective to find out. You can blow air, you can do the glasses. So good scope in computational dynamics. There are CFD softwares. So these are the important commercial packages. This is resource sources. You can go to flame.com, cvdossi.com, and cfdonline.com. There you can have a lot of projects solutions you can identify different kind of what they others carry out. So this already told you some companies. So these are some websites. So any queries, always you are welcome. This is my mobile mail ID. This is my mobile number. So thank you very much for your patience. Thank you.